At the moment, from ETH in Zurich.
Oh, Zurich, yeah.
Yes, yes. But I'm based in Singapore.
Yeah. Oh, I see.
Yes, yes, yes.
But at
Because
the moment, you are in.
Yes, at the moment I came to Tehran to visit family, so we are staying in Tehran at the moment, in Iran, for the moment.
Good, good. It's
Yes.
too hot, no?
Okay.
Oh yeah, very
Is it?
hot, almost 40.
Yes.
Okay, guys, I think we need now to start. I think we are
Sure.
already live on Facebook. So it's a great pleasure to have here Dr. Javadian, who is a senior researcher at the Chair of Architecture and Construction at the Future City Laboratory. He is a PhD, and his research focus is on alternative composite fiber materials as reinforcement systems in concrete application. He also got a Smart Innovation Grant at Singapore. He's also worked in the bamboo team in Zumtobel Group Award. And he works between Singapore and Zurich. And he is a member of the American Concrete Institute and also of the Iranian Concrete Institute. So he did his bachelor degree at the University of Tehran in Iran. And at this moment, he is having his research mainly on fiber materials and reinforcement. And this afternoon, he's going to talk with us about the use of bamboo in construction. And I have the great pleasure to have here as panelist Professor Khosrow Ghavami, that is our
Thank you.
main expert in bamboo in Brazil, one of the main in the world. Professor Normando Barbosa from the Federal University of Paraíba, and Arash Azedeh, that works here with me at Nomatis at the Federal University of Rio de Janeiro at COPE, but also at the University of São Paulo as a research fellow in the group of Professor Homer Savastano, and Dr. João Kraus, that also did his PhD on bamboo under the supervision of Professor Ghavami a few years ago at PUC. So it's a great pleasure to start this discussion, Dr. Javadian, and you please have the word to deliver your talk, and later we can have the discussion, and then with the panelists, and then later we open for questions from the audience. Thank you very much for being with us at the Brazilian Society for Non-Conventional Materials. It's a great honor for us.
Thank you, Professor Romildo, and I'm very happy and honored to join this talk today. Very good afternoon to everyone who are watching this and attending this talk. So, and I would like to thank Professor Romildo, Dr. Arash, and Professor Ghavami for being here tonight. Tonight in Tehran time, and of course your afternoon time. So let me share my screen. So can you see my screen?
Yes, we can.
Perfect.
Yes, please.
Perfect.
Yeah.
Perfect. Great. Again, very good afternoon to everyone. And my name is Alireza, and I'm doing my research back at the Future Cities Lab in Singapore, which was set up by ETH University, ETH Zurich in 2012 to do research between Zurich and Singapore with the invitation of Singapore National Research Foundation in 2012. And also I'm working with Karlsruhe Institute of Technology in Germany. So this is also my next move to continue my research. A very quick outlook of today's presentation. I start with a very short introduction, a quick research methodology of our research, my research mainly on bamboo composite materials, some of the applications that we have worked over the past couple of years, and finally, I thought it would be very interesting to have a quick heads up on our future cooperation, hopefully with your very good team back in Brazil. So the reason that we started in this research basically in 2012 was the fact that we were looking into urbanization. And when we started to do a little bit of a research on how the world urbanization and urbanized population looks like, we ended up having this map. As you can see, this map was generated in 2012 to 2015. You can see countries like in the Asia, Southeast Asia, you can see Indonesia, you can see countries like Philippines. More than 60–50% of the people are living in urbanized areas. If you look into Latin Central America, where Brazil is located, this counts up to 85%. What does this number mean to us as architects, as engineers, is the fact that all this means that we need to look into how we can provide the basic infrastructure for the people who are moving into urbanized areas. In 1950, only less than 1% of the people were living in megacities, and only 5% in medium cities, like 1 million to 5 million population. But in 2030, the estimation is that more than 13% of the people living in medium cities, and that creates a big challenge for the government agencies, for the administrators, for the industries, and for building and construction industry, because we need to provide basically these people with housing solutions. So this was our main challenge. So when we started our research, after almost 6 months, we started to develop a problem. Not develop the problem, but to find the problem. By 2100, globally, we would need more than 2 billion new housing units. At the same time, we are working with finite material resources. And this demand is more I would say more acute in developing countries like in Southeast Asia, like Indonesia, like Malaysia, or in Central Latin America, like Peru, like Ecuador, like Colombia, and in Africa, like Ethiopia, like Kenya. So if you look at the materials that we as engineers, as civil engineers, or even as architects are traditionally using is a steel. Unfortunately, steel has a big challenge for us because iron ore is not going to be renewed over the next couple of years, but of course over the millennia. So we have limited resources of iron ore. These numbers were produced by Forschung project in Germany in 2005, almost 15 years ago. And as you can see, by the pace that we are using iron ore, not just for the building industry, for many industries like car industries, like many other industries, everyday use, we had only less than 100 years left in terms of the resources of iron ore that we have to finish basically the iron ore solutions that currently exist in the Earth's crust. Same for concrete. So for concrete, even though it's a very cheap material, may not be very sustainable because almost 77% of the global CO2 emissions are contributed by the cement industry worldwide. And this means that in terms of environmental factors, not just in terms of sustainability, when we talk about environmental solutions, concrete or even steel might not be the right solutions. So we have started to think, or we started to ask ourselves, what would be an alternative? But before I jump to an alternative, which every one of you knows what I'm going to talk about, I would like to talk about our hypothesis of our research. Normally I don't show the hypothesis of our research, but here, because I'm talking to many of you who are basically experts in the field. This was very challenging for us because we were not sure which direction we would like to go. And therefore, this took us almost 2 to 3 months to formulate the hypothesis of our research. So finally, we made this that it is possible to develop high-performance composite materials from alternative and renewable resources that can be designed to have the necessary properties and to be applied in the building and construction industry. As you can see, our main focus was to use alternative and renewable resources, but for the building and construction industry, from technologies that are already in the market, composite materials. It's a very quick outlook of our research methodology. As you can see, what I would like to highlight in this graph would be the fact that we worked with industries. This was very, very important for us because we were new in this field, and we also wanted to ensure that we have access to the latest state-of-the-art research in terms of fibers production and in terms of the adhesive system and in terms of composite fabrication. And of course, Singapore made this very good and very possible for us because we had very big corporates or companies or industries from Germany, from Switzerland, from across the world have offices in Singapore, and they have set up their R&D, the Research and Development Center, back in Singapore as a hub in Southeast Asia and in the Asia Pacific, which made the collaboration very possible. So we set our research lab in Singapore in 2013 after almost 1 year of preliminary research and understanding of what we want to do. So the grant that we received was from Singapore National Research Foundation, 80%, and 20% from Swiss National Research Foundation. We call it Advanced Fiber Composite Laboratory because we were not still sure we are going to use bamboo fiber. So we call it Advanced Fiber. So we wanted to ensure that it remains very general. So if we change the fibers, we still have the same lab. A basic setup of the lab in 2013, of course, now looks very, very much different. But we started with the machineries that were already existed in countries like China, in Indonesia, for the wood factories, and even for the bamboo industries, because the bamboo industries back in 2012, 2013 were not so interesting for even the Chinese. So we started to modify and design some of these machines ourselves, but we made it, most of them, back in China, in the factories that we were collaborating, as well as in Germany. But of course, in terms of pricing, when at the end we started to look into more to China and Taiwan. So this is a very general slide. Normally I present to everyone, but I should not have it here in front of many experts that are seeing this presentation. But this was very important to make sure that the Singaporean government, the Singaporean industries, and the Singaporean agencies, and especially in Southeast Asia, they understand this fact. And I had a very hard time to convince them that bamboo is the future of the building material, because Singapore is highly urbanized. You rarely see a single column of bamboo in Singapore. It's almost 85% urbanized, and you have some forests left, but in the forest, of course, you don't see much bamboo. And many Singaporean, even my students, they didn't know what is bamboo. But if you go to Southeast Asia, you go to Indonesia, if you go to Thailand, you see bamboo plants. I'm sure, like as you see in Brazil, along the roads, in the normal villages, in the small towns, you see a lot of bamboo. But in Singapore, unfortunately, you don't see it. And when we started to talk about bamboo in Singapore, they look at it as a poor man's timber. And this was, of course, very hard for us because we wanted to promote using bamboo. So we started to showcase that the fact that bamboo grows much faster than timber. If you look at oak, for example, you need at least 80 years, but for bamboo, you only need less than 5 years. And we started to test some bamboo from this region. So we started to test some bamboo fibers from Indonesia, Dendrocalamus asper from Indonesia, from island of Bali. And we tried to convince them that, you see, the bamboo fibers from Indonesia, just a neighboring country, has a strength of almost similar to, very close to carbon fiber. So in terms of mechanical properties, in terms of sustainability, in terms of availability, bamboo is the right solution for future of building materials. In terms of access, Singapore is very well and strategically located and close to many bamboo plantations near Southeast Asia. So we started to collect bamboo from this region, from Thailand, from Indonesia, from Malaysia, all these countries, around 13 countries. We started to collect bamboo from this region. We traveled to them. We look at the bamboo plants there. We started to test them from different ages. And at the end, many mechanical properties we tested in terms of tensile properties, in terms of bending capacities, flexural strengths. But one of our main challenge, our team challenge, was the lack of standardization. So of course, ISO has a very, I would say, outdated standard for testing materials like bamboo. But unfortunately, many of those standards that we started to follow, we had problems, because when we changed the bamboo species, either the bamboo column was very thin or the bamboo wall thickness was very thin, we were not able to follow the standards, and that made our testing a little bit tedious and time consuming. So it took us almost 1.5 years to test most common bamboo species from this region. But what was interesting for us was that the most common bamboo species in Southeast Asia was Dendrocalamus asper, and this is the some of the classification that we did. So we classified these bamboos according to their wall thickness, as well as according to the call diameter. The maximum strength in terms of tension we found was 340 MPa, and in terms of lowest was 193 MPa. As you can see, there is a wide range of mechanical properties between the bamboos that we collect. Even the same species grown in Southeast Asia, but different regions, they had different mechanical properties. And this shows another challenge for us where we wanted to promote bamboo, because the industry and even the government agencies like the building and construction industry in Singapore, they see this as one of the main challenges, how we can standardize bamboo for being used as a building material. But what we did some statistical and mathematical modeling to see how we can estimate the mechanical properties without testing them. So this was very important for us, because when we wanted to order some bamboo, for example, from Indonesia, we didn't have to travel all the way, or we didn't have to necessarily ask them to send us few samples. So what we did based on more than 5,000 samples, we did some basic formulations that how to estimate with a good basically approximation, how to estimate the mechanical properties like elastic modulus, like modulus of rupture, like compressive strength, like tensile strength. So we had a very good estimate before we received the bamboo. We could tell the farmers that no, don't cut that bamboo, we want this property, so please cut the bamboo with this specification. But the next step was for us that how we want to industrialize bamboo. So as you know, bamboo in terms of raw shape, in terms of natural form, have been used many centuries around the globe. This was very interesting for us. Of course, most of our knowledge came from papers that Professor Gabami wrote about the use of bamboo in Brazil and many countries that he has worked over the past couple of years. But we wanted to see how we can promote bamboo as a fibers in a new technology. Not new technology, but rather I would say high-tech technology. So we started to look into composite fabrication, basically fiber reinforced polymers, but using bamboo fibers. But our main challenge was that if we wanted to use any type of adhesive system, we had the challenge of sustainability, because we wanted to promote bamboo as a sustainable materials. At the same time, if we were going to use non-sustainable synthetic adhesive system, then we had a challenge how to convince the industry to call or label our product a green product. So we had 3 criteria to choose our resin system. VOC free, had acceptable mechanical properties, and should have bio-based content. So we worked with 2 polymer companies. Some of you may have heard them. One was the Rehau from Germany, and the other one was Wacker, also from Germany. It took them almost, I mean, it was a very progressive process, 2 years to reach to a stage that we had a resin system that was comparable to a system like Araldite, that had mechanical properties that we wanted and had high bio-based content that made the recycling possible. The next step was to process the bamboo into strands. To process the bamboo into strands, so we used the machineries that were being used in many countries around the globe, but we did the modification in terms of how we can get these strands into the right shape, right thickness, and with the right fiber diameters. The next step was how to interact the bamboo fiber with the resin matrix. And finally, we use hot press compression molding system basically to compress all these impregnated layers together. So the combination of what temperature would be the hot press, the pressure of the hot press, and the time was very important. These 3 stages, as you can see, took us almost 2.5 years to reach the final product that had the properties that we wanted. So I just go through some of the pictures of the samples that we produced. This is samples that we use for pull-out tests for using in concrete. This is a sample that we used for making a house in Indonesia that I will show later on. Again, regularly we had to do testing in terms of mechanical properties like tensile strength, elastic modulus in terms of tensile along the fibers and across the fibers. Again, bending along the fibers, across the fiber, elastic modulus. So over the past, I would say between late 2013, when the lab was fully set up, and until 2000, I would say late 2017, where we were already sure that this is the product that we wanted. We tested more than 10,000 samples in terms of bending, 8,000, more than 8,000 for tensile, to have regularly test samples also from variety of the bamboo species that we had in Indonesia. So I would like to pause a little bit here because these are many numbers are here to digest. So I would pause a bit here. These are the properties that we achieved at the end of 2017 based on these tests that I have mentioned earlier. As you can see, in terms of tensile strengths, we had a range of between 200 to 300 MPa, MPa, Newton per square millimeter. When you compare it with glue lamp, this is the glue lamp that is widely available in Singapore. They use it recently for non-structural walls in Singapore, but also imported from mostly from New Zealand and Australia. From Germany. In terms of bending strength, flexural strength, as you can see, it has high bending capacity, 150, almost 10 times of the glue lamp. In terms of compressive strength, the range is wider. Again, depends on the fiber, depends on the density of the product, of the natural material of the bamboo, and depends on where we collect or where we can harvest the bamboo. In terms of elastic modulus, basically how tough it is, again, is much better and more superior to glue lamp. In terms of density, of course, is not as light as glue lamp, but is not also very heavy. Definitely is heavier than water, but is not as light as glue lamp. But again, this is very important because normally we should compare the strength to weight ratio. So when you compare the tensile strength to density, the ratio, and when you compare the glue lamp tensile strength to the density, again, the bamboo composite stands much, much higher. Again, so I would like to move on to the next step, which is the applications. The very first application and the title of my PhD thesis back at ETH in Zurich was how we can replace steel in concrete by our material. So in this part was made, I would say this, I'm very, very happy that Professor Kavami is here tonight, because most of my work that I have done and literature review that I have done was, I learned everything from him, and his works over the past 20-30 years was very, very promising and gave me the basically momentum that is possible. If natural materials can be used in concrete, then why not a bamboo composite cannot be used in concrete? So we did a lot of pull-out tests to see how is the bonding mechanism between concrete and bamboo composite materials, because normally steel has a very good bonding between the two materials, but we wanted to ensure that this material also has a good bonding. What we did, we applied some type of coatings that we got it from the two chemical companies that I mentioned earlier, because chemistry was not my capacity or my expertise. So I had to get that knowledge from somewhere and get that expertise from Wacker and Rehal. So this was the bamboo composite reinforcement system that we developed in Singapore. Even the stirrups, the shear reinforcement, as you can see, are made from the bamboo composite materials that we developed in Singapore, the longitudinal reinforcement, the whole system. And the idea was that, the earlier idea was that we could have a prefab system. So basically, this whole element that you see for reinforcing.
Tem que ser.
Hello? Was to reinforce the beams of up to 2 meters because of the capacity of the testing machine that we had in Singapore. The whole reinforcement system was less than, if I'm not wrong, 2 kg. So this could have given the industry the flexibility in terms of prefabrication. Some of the testing that we have done, of course, we followed ECI, FRP standards for designing the beams. We wanted to see where the shear failure happens, where the tensile failure happens, where the compressive failure happens in concrete. But most likely we wanted to have the tensile failure in reinforcement in our bamboo composite reinforcement. The results were quite promising. We published a paper on it. Even my thesis is also available at ETH library that I have explained all these calculations in very, very much detail. The next application that I started to work after I defended my PhD thesis was the fact that how I can reduce the cross section of the glue lamp beams, because glue lamps, when you want to use it for higher than one story beams, then you have to have more layers. Then you would have a bit heavier elements, and you would have much more material. So we wanted to promote sustainability, and we wanted to promote higher weight to strength ratio. So what we did, we said, okay, if you don't want to use the whole sections out of glue lamp, you could use part of it out of glue lamp, and then you reinforce it with our materials. Again, the results were quite promising. We were able to achieve 20 to 25% increase in mechanical capacity, and especially in elastic modulus in terms of deflection. So this was the idea on how we can promote our bamboo composite materials, especially in countries like Singapore that are a bit reluctant to use anything that's related to bamboo. And this was very well received by the construction industry in Singapore. And still the research is ongoing because we need to get a lot of certifications. We need to do more full-scale testing. Therefore, the research is ongoing, and I'm going to do some of this tests back in Germany in KIT. Again, you could use the whole element out of bamboo composite. So instead of having just reinforcing the glue lamp or just using as reinforcement, we see a very good high potential to use the whole element. So if you have a beams out of concrete, you could replace the whole thing out of bamboo composite, because in terms of strength, compression, in terms of bending, has a very good high capacity. Or if you want to make it lighter, then we can use what I call hollow sections out of it to build the columns or to build basically piles. And finally, implementation. So we were lucky enough that some of our partners in Indonesia that we were collaborating connected us to municipality of the Batam. Batam is one of the largest islands in Indonesia. Indonesia is near to Singapore. It's only 40 minutes by boat ride, And they wanted to promote sustainable housing solutions in this island. And they invited us to submit proposals. One of the proposals that we submitted, this is the picture that you see. They wanted to have a kampung life. Kampung in Indonesian language means village. So they wanted to promote sustainable villages, but not turning a village to towns, but rather people have still a village feeling, but they live in sustainable townships. So we started to look at how we can use our materials to build housing. So you can see the models of the house here. One of the criteria that they told us was that they don't want to see the whole thing out of bamboo composite, because they see this as a cultural shock. So they want to have a combination of traditional materials like concrete and our materials. So we accepted this because this was a very good opportunity for us to showcase that it's possible to use our material in a natural environment. So it's quite strong, it's quite resistant to fungi, it's quite resistant to insects, and it's not like natural bamboo that you have a lot of problems with insects or with UV, or you have to protect it. Therefore, we accepted that offer, and we did that house in Batam in Indonesia. July last year, we officially launched the house. It was our very first proof of concept that were warmly basically received by the Indonesian ministries as well as our Swiss ambassador in Indonesia. And it was a very, I would say, a small milestone for us after almost 7 years of research. And as you can see in the first floor, what we did, we use our material as a door frames, as a window frame, as a shading frames. Second floor, we moved on interior, we use our materials as a cladding system. And the third floor, the final floor, we use the columns, as you can see on top, the columns and the beams again we use. So as you can see, gradually we move to replace the conventional materials with our materials. So instead of telling them, okay, you see, we can use the whole material for the whole house, no. We said, okay, gradually we can do that. So we wanted to showcase that it's possible to use our materials. As you can see, the second story, we had the Hebel blocks, but the third story, we replaced the Hebel blocks with only 10 mm, or I'm not sure, maybe 15 mm, our bamboo composite boards, and also the columns that you can see around the boards. So I would like to move on to the next step, and I would like to see what would the panelists would like to have or to like to discuss. In late last year, we registered a spin-off called Vidus with the idea that we can commercialize research. So basically, we want to bring our research to applications. So ETH Zurich supported us to at the earliest stage, giving us the access to some investors, to venture capitalists, as well as some industrial partners, to raise a little bit funding that we could do a little bit of like promotion for our startups. So now currently we are at the stage that raising funds to set up our very first factory in Cambodia, near to Singapore. The reason that we chose Cambodia because it's close to Singapore, and as also they have access to large bamboo plantations. The aim or vision or aim of Vidus is to revolutionize the building and construction industry to provide an environmental friendly and sustainable alternative to traditional building materials while contributing to the development of a sustainable economy. So Vidus collaborates currently with Singapore ETH Center, basically the branch of ETH Zurich in Singapore, and with Karlsruhe Institute for Technology back in Germany. So together we are trying to scale up the process that we developed in Singapore and to commercialize it. Of course, we have some industrial partners that are in the stage of discussion and negotiation that I could not name them here. But very important part, of course, is how we can address the sustainable development goals. Based on our research, we see that we can address the sustainable SDGs with at least 6 of these goals. No poverty, so when we create our factory in Cambodia, we can create new bamboo plantations, we can create new jobs, we can employ locals that don't have a job. So this is very important for countries, for low-income countries like Cambodia, like Vietnam, that they need new ideas for job creation. Again, clean energy, so of course not the whole bamboo could be used for this process that we have. Some of it that could be used for biomass for producing electricity, especially in these countries that they don't have access to electricity all over the country. In terms of sustainable cities, of course, bamboo can be used for affordable housing solutions. Goal number 12, we can use green sustainable alternative like bamboo composite to replace steel, concrete, and glass, at least in this region that they have access to bamboo. And bamboo itself, as all of you might have been aware of, that is a natural carbon sink. So it absorbs a lot of CO2 compared to even timber. And finally, if we can have more bamboo forests and plantation, we can restore a lot of degraded land. So this is also one of the challenges in Indonesia, because they have highly grown palm to basically get the oil from it. But after a while, when the palm oil is done, after a few years, the land is degraded. So they cannot grow more palm trees. So they have to restore the land. And to restore the land, bamboo is one of the great alternatives. So the next step of my what I would like to do my research, and also at our startup as well as in our university, is to develop adhesive system that we can move towards more biocompatible. So what we had so far was bio-based, but we want to move to biocompatible adhesive system that gives us the opportunity to fully recycle our materials. The next research idea that we have at the moment is to improve the resistance against UV in the harsh environment. So we tested in this region, works very well. But what we would like to see, we would like to see how this reacts in environment like temperate environment like Europe or like Northern America, where we have a harsh environment. Third one would be to develop the microstructure for sound and heat insulation. At the moment, the sound insulation is not that great. Heat insulation is not bad, but again, these two properties, they have to be improved if we want to commercialize it. And finally, large scale testing and full size elements to be tested is very important. This is something that we have to continue, because we need, if we want to upscale and if we want to commercialize it, we need to get certificates. To get the certificates, we need to ensure that the full size elements, they have lowest basically standard deviations, and the properties remain the same across the elements. This would be one of the very important, I would say, research ideas that, or research directions that we have to continue for the next year or so. This was my last slide, and I'm very happy to hear your thoughts and comments and discuss more with you. Thank you.
Amildo, you're muted.
So thank you very much, Dr. Javadian, for your presentation. It was a very inspiring presentation, beautiful pictures, and very well presented. Thank you very much. I'd like to pass the word to my colleagues in Professor Gavami. We can start with you for your comments and discussion with Dr. Javadian about his research. I think your microphone, Gavam, you need to turn it on, please. Carol, can you unmute him?
Hello.
Yeah, now we can hear you. Okay, thank you.
Oh, you can hear. Good. I'm very glad that Dr. Javadian, also an Iranian terrorist, started this research there. As you mentioned, I have been in Singapore, which was very advanced with the other countries. I've been in China or others in 1988, and I gave a lecture in that time on bamboo, and I really enjoyed your country, Singapore. And I think I'm very glad that you're doing this research on bamboo. What I have looked at your presentation, I know is a short time. How did you treat your bamboo for the reinforcement? Did you treat it or not? Because the way you have shown your slide, as if it is not treated.
Yeah, thank you, Professor Ravami. Yes, sure. Yes, we treated. Unfortunately, I could not present more, but the treatment was done in a lab. So what we did, we get the bamboo, we cut it into basically the strands. What we did next was to boil the bamboo strands together with NaOH. NaOH basically what they call it, hydroxide sodium, NaOH solutions basically. So the idea was to get the lignin as much as possible out and increase the fiber density, and also to make sure that the insects, like any type of insects or fungi, could not grow. So this helped us a lot, because after we tested them in the environment chamber, in the weathering chamber, we had good results. So the treatment was very simple. So basically, boil the bamboo strands together with the NaOH solutions. I think 1 to 3% solutions.
Yeah, but you say, okay, that's the bamboo treatment. But
yes,
you use your bamboo strip as a concrete, you would not have bonding with the normal bamboo.
I know your question. Very good. Sorry. I thought you were talking about the composite fabrication. No. Okay.
No, because I look the way you have shown, as the bamboo surface is not treated.
Sure. Yes, it was treated with a formulation that was provided by company Rehau to us. So it was a type of, I would say, epoxy coating that applied on the surface. And that helped us to improve the bonding mechanism. So we tested many type of coatings. We tested water-based coating. We tested even with sand particles coating. But the coatings that was formulated from this company Rehau gave us the highest bonding mechanism between the bamboo composite and the concrete.
I see.
So that's why that was the basically best formulation that was achieved by the company and was provided to the university for us to use.
Yeah. Are you not using? Well, I mean, Singapore.
Sure.
No, I mean in practice, because now we do in Brazil. There are people from Europe work with me, and we build a lot of houses and things reinforced with bamboo. How is the situation there?
Yeah, unfortunately, this is a bit disappointing. Singapore, as you said, is very highly advanced and very well developed. So a new material to be able to be introduced into the construction industry is very challenging. So we had a hard time to convince them. That's why we had our POC in Indonesia, because in Indonesia, we have to follow rules, but they are more open. Singaporeans, unfortunately, they are not open. If you test this material, let's say in Brazil, or let's say in Germany, and Germany say, okay, this is good to use, then Singaporeans will follow. But if not, they don't want to take the risk first. They would rather prefer someone else has taken the risk before, tested the material, certified, and then they say, okay, let's use it. This is the same thing that happens in Singapore for even for glulam, for GLT, even for CLT. They were very reluctant to use CLT until 2 years ago, but once the Germans and the European code came, the Eurocode 5 came out, they started to think about it. And that's why I heard that last year in a congress that they're going to build a new 7-story house out of CLT in Singapore after, I would say, many years. So this is a bit a big challenge for us at the moment. That's why, as you see, we moved a little bit from bamboo composite reinforced concrete to other applications, like just not use even concrete, but would rather replace the whole concrete elements with the bamboo composite, because they are more open to that. Because when we say reinforcement in concrete, they say, oh wow, so you're using two things in one material, a new composite. So how for us, convincing them was a big challenge. And still we are working on that. We never gave up, but we see the opportunity in competition with CLT and with competition with glulam. Because when you use the bamboo composite standalone, then we say we have a direct competitors. If you tell the contractor that can use CLT, can use GLT, why not use bamboo composite? It's the same thing. Instead of wood fibers, we are using bamboo fibers. So that's
by the way, yes, I'm listening.
Sure. No, I'm just listening. Yeah. I'm done.
Yeah. Are you in contact with Chinese? Because I was, and we had a conference, our NOCMAT conference in Wuhan, and they are using bamboo reinforced concrete in a big scale, and that's done by Professor Yang at long time. He's a Chinese American, and he builds. So, are you in contact with them, or?
Yes, I'm contacting with Nanjing Forestry University with Professor. With 2-3 professors there. And yes, I've been in contact with them. They're also now developing, they are part of the ISO standard. So they are the ones that basically are upgrading the new ISO standard for composite materials made from bamboo, because they also do research on composite bamboo, but with different technology. Yes, we are in contact with them, and they're very much actually pushing the bamboo industry back in China. But they also face some challenges, of course. That when I visited Nanjing few times, we visited many of these houses that they built. Some of them they couldn't get the license that people could live in, so they are basically not being used, but would rather use as a showcase. But I'm sure that they can push this a bit further, because Chinese a bit more open to new materials, and especially they have a lot of bamboo, and the bamboo industry is quite big in China.
And what type of bamboo are you studying? I mean,
At
the
the moment,
species.
a species that we use is a Dendrocalamus asper.
I see. Thank you.
Dendrocalamus
And you get it from in Singapore.
No, from Indonesia.
Oh, Indonesia. I'm sorry. Yeah.
Yes,
Okay.
because Singapore has no bamboo, unfortunately.
Yes. Yeah.
This was a big challenge for
Okay.
us as well.
Thank you very much, and very nice presentation. And I
Thank you,
wish you
Professor.
success.
Thank you so much. Thank
And
you. I'm very happy to
yeah,
glad to see you.
yeah, the
Thank you.
same.
Thank you.
Thank you
Yeah.
for your
Bye.
participation, Gavami.
Thank
I
you.
take the opportunity of Gavami's questions, and I would like to know one thing that from what I have noticed, the elastic modulus of your material, of your bamboo strips, they are around 20 gigapascal.
20,000, yes.
Yes, 20 giga. So which kind of concrete did you use? I think the tension stiffening behavior may not be very good if you use concrete of normal density. Did you use a lightweight? Did you use a lightweight concrete? What kind of matrix did you use to reinforce? Because otherwise, it's not going to be very good in terms of tension stiffening behavior. Which concrete did they use?
So we use a very good question. Yes, the concrete that we used was a lightweight concrete, and the grade was between 20 to 30 MPa. So we didn't want to have high strength or high density concrete. It was lightweight, and of course the compressive strength was between 20 to 30 MPa. And this was the reason that we chose, again, in line with what you have mentioned correctly, and also in line with the idea that we wanted to ensure that the most common concrete grade or type that is being used in this region is what? Because if you want, this is the most common concrete grade used in this region, and we wanted to showcase that you don't have to use normal strength concrete or normal weight, but rather just use a lightweight concrete. So at the end, you have the advantage of the lightweight structure too.
Okay, and the volume fraction of your strips, which are, how much resin and fibers did you get? Which proportion in terms of volume?
So we had a very different range of fiber to resin proportion. The reason was the fact that we had Dendrocalamus asper from different regions. But the most common one from the island of Bali that we use, the ratio between the resin to the between the bamboo fibers to the resin was 85 to 15%. So 85% bamboo fibers, 15% resin system. But we also did have 90 to 10. We also did have 80 to 20.
Okay, so all above 80%.
Yes, yes.
Okay.
Average was about 80%.
Okay, thank you very much. Let me pass to our colleagues. Then later I come back again. Let me ask Professor Normando Perazzo to make his comments and discuss a little bit with you about your research.
Thanks, Romildo. Dear Ali, it was nice to hear you.
Thank you.
You talk about a composite, bamboo composite.
Yes.
With a resin. I was curious because I did not understand well. It was a composite with a matrix, polymeric matrix, and fiber reinforcing this matrix, or just a bamboo coated by the resin. I didn't understand well.
Sure. Thank you, Professor Normando. Yeah, maybe it was a bit fast that I moved on to the slides, but no, it's a fibers reinforced polymer. So it's not just a bamboo coated with the resin. No, it's a fiber reinforced polymer.
you didn't show the fabrication.
Yeah, sure, sure. Yeah, I mean, because I had many slides and I was a bit afraid of the
Yes.
time. But if I have your email, then I can send you more information. Or
Okay.
of course, you can see also our papers.
Okay. I think that to use these materials as reinforcement in concrete is not a very good idea because elastic modulus is low.
Sure.
So we cannot use in big beams. Just in small beams, you can use this material because the placements are big, né? And
Sure.
the cracks will appear
Right.
along in the beam. But this material, it seems to have a very good potential to use, I think, outside the concrete. Many other using replacing wood and other materials. I think it's a very, very interesting. If we can contact you by email, I am interested to see how did you produce this material. Okay.
Sure, definitely, yes.
And thanks a lot for your presentation. It was interesting to see that an Iranian is working with bamboo. Very good.
Thank you.
Very good idea.
I was inspired by Professor Ghawami, of course.
Yes, very good, very good.
Thank you.
Thanks a lot.
Thank you very much,
Thank you so
Norma.
much.
Yes, thank you for your comment. Yes, thank you for the discussion. And now I would like to ask Dr. João Kraus to comment also and to present his questions to you.
Okay. Well, thank you very much for inviting me to participate on this debate. And first of all, Dr. Javadian, congratulations. It was a splendid research and splendid products. I very much enjoyed your presentation.
Thank you
very
so
much for being here.
Thank you.
And I have some comments indeed.
Sure.
First of all, it was a very impressive laboratory and I couldn't let off notice the machinery to produce the laminates and to produce the scrimblers that you are using.
Yes.
You've told that it was a fiber reinforced polymer, but I've seen it looks a little bit like the bamboo scrimblers, which the fibers are not completely aligned. They're a bit curved, right? Is that it for first? Is that it? So, okay.
Thank you. I can answer first?
No. Yeah, please.
Sure. So maybe I will answer first so we can move to the next question. So yes, we learned from the bamboo scrimber that the Chinese make, but when we tested those and when we did that the same thing, we couldn't achieve the mechanical properties that I have shown you. Therefore, we started to modify the machines and we started to modify the machines in a way that we can maintain the fiber directions. We can make the fibers as thin as possible, which Chinese, they could not do it. So therefore, through modifications of the machines that we asked them to produce, we were able to achieve the strengths that you have seen. So the bamboo scrimblers, we did the production the same, but due to the fiber orientation that you correctly mentioned, we could not achieve the strengths that we wanted. It's good enough for flooring, it's good enough maybe for non-structural elements or even semi-structural, but if you want to use it as a beams or columns, we were aiming for high strengths. That is basically convincing for the engineers, convincing for the industries. That's why we started to do that modifications to the machines. But what you mentioned is correct, but we moved away from the scrimber.
Okay, perfect. Another thing, well, if you're selecting the fibers, of course, you're losing a lot of material. You have to concentrate your attentions on a specific part of the bamboo.
Right. Right.
So you told it would be used as a bioenergy, right? To generate energy.
One of the ideas.
Yeah. And also for agriculture.
Compost.
Yeah, you can use for a lot of things. But anyway, you also could use the other part of the bamboo, which are which have a lower density, to combine with the material, which is high density, and not high density, but much higher, has a much higher density. Yeah, because of the strength. To achieve that properties that they've mentioned in the end of your presentation about heat and acoustic properties.
Right.
Because it's a trade-off, right? If you're if you're increasing you will increase the transmittance, the thermal transmittance, if you increase the density.
Right.
If you're lowering the pores, if you're diminishing the empty spaces, you will be decreasing the heat and acoustic properties, just like concrete is very bad on these properties. Yeah.
Concrete is bad.
yeah, for these, yes. Okay, this is one.
No, it's a good point. Good point. Thank you for the comment. Very good point. Yeah, but that's as I said, our main focus over the past couple of years was not so much on heat and sound installations, because I'm a structural engineer, and then I studied a bit of architecture, so it was not always on my agenda. But now, when we have the right material, then we think now is the right time for us to move the research into a direction that we can enhance the heat and sound installation. Definitely, yeah.
I just don't think that you could do it about treating the microstructure.
Okay.
You may have
very good.
Maybe it's better to combine things with macrostructures, not microstructures, right?
Sure. No, I'm happy to hear more from you after the talk. Maybe we can get connected.
Yeah, of course. Yeah. Perfectly. And
thank you.
I did the other path. I am an architect, and I know a bit of engineering. I've done my master's. Yeah, I've done my master's and my doctor's degrees in civil engineering with Professor Gavami.
Very nice. Very nice.
Yeah. And another interesting thing that I've noticed is that your armor in the concrete, you've used squared profiles, which would have an accumulus of tension and along of the bars, of the rebars. You could try to use cylindrical profiles, which would not be that hard to achieve.
Well, it was very hard for us. We did try that. So at the end, as you can see, the square that we used, we had the round edges. So we had the round edges because producing the circular
it's much better.
Yeah, it was much better. So we had the sharp edges. Then the test was, as we mentioned correctly, was very good. But then we started to have the round edges. It improved by almost 70–80%. But commenting on the point that to have a circular, you mentioned circular, right?
Circular, I mean circular or even like a bit of starry shape.
Okay, now I got you. Okay, yeah, sure.
That you would increase the bonding, right? Because because of the geometry, you increase the surface, and it's not that hard to do because in common carpentry and carpentry, there are some instruments, some tools to make it, right? So you may have a square profile for first, and then just push it on some tool to achieve these forms. And maybe you could improve the bonding and the behavior between the concrete and the bamboo.
The bamboo, yeah. Thank you. Yeah, it's a good comment. Sure.
Yes, and another thing, I've noticed your specimens for the tension tests. and I've worked a little bit about this on my thesis. One thing that I would tell you to try, which was interesting for me, was to try to adopt the ASTM 3039D.
Yeah.
Yeah, and we've got better results using this than the bamboo standards.
Sure. For testing the natural bamboo, you mean?
For testing natural bamboo or the composites. The natural bamboo is interesting because you may vary the width of the body of proof of the specimen according to the width of the wall, of the thickness of the wall.
True.
So, and you can use simple laminas.
Sure.
You don't have to do body shape, but like bone shaped specimens.
Bone shape, dog bone. Okay.
Yeah, you can use them straight.
Sure. Yeah, but this was one of the challenges that we had. So some of the samples we even didn't do the dog bone as you mentioned. We just did a flat strip, and then we just tested, but with some coupons attached to the samples to ensure that we have a bit of thickness.
Yes, you use tabs. Right.
Yes, yeah, exactly.
Yeah.
And the result, of course, was not so much different, I would say. But a little bit, yeah.
Yeah, the wedge shaped, I really had no improvements. In fact, I've got the opposite. I've got worse results with the wedge shaped in comparison to the flat ones.
Yeah.
So anyway,
thank you.
First of all, congratulations. It was a beautiful work, and special
Thank you so much.
You've got this POC, which was very interesting to apply it on a city to people for living. Perfect.
Yep. Thank you so much
for the presentation.
Thank you very much. Thank you.
Thank you, João, for these comments. I would like to ask my colleague, Dr. Arash, for his comments and questioning.
Hi, everybody. Thank you very much. Dr. Javadian was a great presentation for us. I learned many things. Thank you very much. Being the last person is very good because every person, 4 person, asked many questions and very nice questions, and I wrote many things, and I think now it's okay, and I don't have many questions. And then something about in fact, the water absorption, if you use, for example, because the concrete needs curing, and when you cure the concrete, maybe happen an interaction between the what do you think about this, and how you solve this problem?
So as you have seen through the slides, so what we did first, we treat the fibers. So we try to ensure that the lignin is much basically get it out. So when you have less lignin, then you have less water absorption naturally happens. Second process was to apply the resin system. So the resin, when we processed with the resin, we impregnated with the resin, and then we have a hot press. You have a composite like glass fibers, like carbon fibers. The water absorption is already very much minimized. The second step was, as I mentioned to the comments by Professor Gavami, applying the coatings to improve the bonding. So we had another coating to improve the bonding between the concrete matrix and the bamboo composite. So these 3 stages of process that we applied on the fibers helped us to reduce the water absorption. So we monitored it. So we had weathering chamber as well as normal just water basins that we put the samples in for over a year. And then we tested again over the pull-out tests, and we tested for the bending capacity. So the result again were quite promising. So we tested without the coating that we applied for the bonding, and we tested with the coating. So without the coating, we had a reduction in the strength by up to 30 to 40%. But with the coating, there was almost like not much degradation over the strength over the 1 year period. But again, these are the results over the 1 year. This test has to be continued. but somehow we stopped the test at the moment due to the funding issues that we had, and also the lack of interest from the government agencies and the building industry in Singapore. That's why we moved a little bit from the bamboo composite reinforced concrete to the bamboo composite elements on its own. But the tests that I mentioned we did over my PhD works were carried out over a year and a half, and the result with the bonding coating was quite promising. Yeah.
And thank you very much. And did you have ever any test about the degradation of this type of reinforcement? What happened for this?
After, sorry?
About the degradation of this type of reinforcement. Do you have any experience? What happened after 2 years, 5 years?
Yes. So we couldn't do like 2, 5, 7 years. We have accelerated testing. So we had the environmental chamber, and we could basically model the environment, different humidity, different basically UV, and different temperature. So we could accelerate the 10 years, 20 years, or 30 years. So if I want to give you some numbers, just very rough numbers that we achieved. So the detailed information is still under investigation. But for example, after 5 years of testing, accelerated, in terms of mechanical capacity, mostly tension and bending, we had a reduction about 5%.
Oh, very good.
But after 20%, we had a reduction of between 7 to 10%. And after 30 years, it was almost stabilized. So we had less than 12, less than 11% of degradation in terms of mechanical capacities. But again, the environment that we tested was mostly tropical environment. We wanted to model the tropical environment. We haven't moved to the temperate environment yet. So we are still in that stage, as I mentioned in my direction of the next type of research that I would like to do, because now I'm trying to do a bit of research back in Germany. So the next step, I would like to see how we can use this type of material in countries, in European countries, or in general in temperate environments.
Very good. And another question, Doctor, about comparing the different types, species of bamboo. Why you try to select, because it's abundant, what's your reason for selecting the Dendrocalamus asper?
The reason that we have chosen Dendrocalamus asper was the fact that it was the most common species in this region, because we were thinking about future when we want to upscale the process, when we want to commercialize this. So it would be very difficult if you have just any type of bamboo. We get it from the nature and then we process it. Then the properties would be different. So we wanted to, from now, standardize it. Because the next step, what we want to promote is to have bamboo plantations. So when we know that this type of Dendrocalamus asper that, let's say, grows in Bali, or let's say grows in Java Island in Indonesia, then when we want to have the plantations, then we tell the plantation owners, so please grow this bamboo, grow this species that we want. Then this species we are sure that has the properties that we want. Otherwise, through our process, we can use any type of bamboo, any species. There is no limitations. The only limitation is just the grade of the strength, in terms of a strength grade that the bamboo has.
Thank you very
It's like using guadua in Latin America. So guadua is one of the most common species, and you have it everywhere. So it's easier to commercialize it and to upscale the process from the bamboo species that is widely available in that region.
Yeah. Thank you very much. I don't have any question because my colleague asked all of them.
Thank you.
Thank you very much.
Thank you. Thank you again for organizing this talk. Thank you, Arash.
Thank you. No.
Thank you, Arash, for your comments. Now we have few questions from the audience, from the people that watched you using Facebook.
Sure.
Okay, so I would like to address some of these questions. The first one comes from Mr. Malay Kumar Dev. He would like to know, he's saying that your material is as strong as steel or even more. and he would like you to explain a little bit these numbers.
So in terms of the strengths, the steel that I presented is S275. So this grade of steel is very common in Indonesia as reinforcement, and also as using structural steel for building houses. So this is the most common type of steel in this region for building low-cost and low-rise housing solutions. And the reason I compared that the strength with S275 was the availability of this steel, and also in the construction industry in terms of access and in terms of price. Otherwise, no. If you compare it with grade 37, 325 or higher grade of a steel, no, our material definitely is not as strong as a steel. Okay,
thank you very much. The second question comes from Vinicius Kraus. He's asking you about the interface between your bamboo composite and the concrete. If you can talk a little bit more about this issue, about the interfacial properties.
Yes, the interfacial is very important, of course. This was not easy to achieve the right interfacial properties, as I mentioned to Professor Ravami and Dr. Arash. So we had to do a lot of processes to ensure that we get a good bonding. One of the processes first was to get the bamboo fibers treated with the NaOH treatment, to get the lignin out to have more fiber density. Second step was to impregnate it with the resin. Third step was to apply the coating that I mentioned to improve the bonding mechanism between the concrete matrix and the bamboo composite. And we have tested those through our pull-out test. And the pull-out test showed good and promising results when we applied those type of coatings. And these are the things that, of course, depends a lot on the grade of the concrete. So if the concrete is even higher grade, then the behavior in terms of interfacial properties would change. But what we tested was mostly for the most common lightweight and average type of grade between 20 to 30 MPa, which is widely used in Indonesia.
Okay, thank you very much. We also have a question here from Manaol from Brazil. He's saying that here in Brazil, wooden construction are marginalized in comparison with steel and concrete. How to find commercial space for bamboo construction in this context?
Well, this question, I think we should ask the panelists, not mine, because I'm not in Brazil. But if I want to comment on that in terms of Indonesia or in terms of Southeast Asian context, because I'm not very familiar with the Brazilian context, but with in Southeast Asian context, I would say in recent years, we are seeing sustainability as the core of construction industry in this region, being labeled as green, being labeled as sustainable, and of course, getting certificates from the government agencies, and even government agencies are pushing construction industry towards more sustainable material. So we see a shift, and a very, very big shift in this region. And I would say in the next 5 to 10 years, bamboo industry would be even bigger and larger than timber industry, at least in this region, because a lot of forests in this region, in Indonesia, in Philippines, in Malaysia, are being cleared to grow more palm oil plantations. And unfortunately, this has contributed a lot to land degradation, to air pollution, and to water resources management. But bamboo is good at all these three. So I'm sure with the support that we get, already we are getting from a lot of government agencies and also from United Nations development programs, I'm sure with the support of people like you, we are able to push bamboo to the next frontier, which would be the next 5 to 10 years. So we need support, and we need people to come together, and we need organizations like INBAR, for instance, to be able to support researchers or to support people like us or entrepreneurs like us to ensure that we are able to push our ideas to the next phase. At least what I see in Southeast Asia, yeah.
Not only in Asia, in Europe as well, bio-based materials are finding a big market. Here in Brazil, few years ago, or many years ago, Professor Gavami has started this association on non-conventional materials. Since then, many studies has been developed, and many people has studied these materials, and I think we have good knowledge now. Normando has just led this Brazilian standard for bamboo construction as well.
Very good.
And I think this we are doing lots of work with natural fibers as well and bioconcrete.
Very interesting.
So we really believe that not only in Asia but also in Europe and in Latin America, Ecuador, Colombia, Peru, I think Brazil also has big chance and good opportunities to use bio-based materials. If any of my colleagues from the panel wanted to talk about this as well, okay, João, please.
I would like it, please. I would like it to have your email. Can I have it? Because
sure. I think we will share it after the talk. Definitely.
I want to send you a lot of two publications we will have about the reinforced concrete, bamboo reinforced concrete, and also a lot of tests we've done with bamboo and several variations.
Sure.
Several treatments, several coating.
Very good.
Okay.
Sure.
If I can have your email,
sure.
Appreciate
Definitely, yeah. I think I don't know. I think we can type
you can type it in the chat later if possible. But
sure,
I think Dr. João also would like to comment something about the question that was made by Manaus.
Yes, I do. Well, we have thank you very much, Professor Romildo. We do have a problem here in Brazil that which is related to insurance and reinsurance for construction. And the problem is that wood is not more widely used, is that you do have some insurance categories, but you do not have any reinsurance categories for civil construction with wood here in Brazil, or it's very rare to find. So this is not an encouraging thing to constructors to build large buildings using wood. And of course, it applies to bamboo as well.
Right. Yeah, it's similarly also, I think in Southeast Asia, almost similar because of the, there is no standards for application and there is no certification. And then at the end, the insurance company, the main challenge is the fire for them. And if they don't insure, then nobody wants to build out of it.
Okay. There is another question here from Vinicius Krause. He's asking about, as Singapore, you said that there is no cultivation of bamboo in Singapore. Then how about logistics and installation for construction using bamboo?
Well, I mean, so Singapore is a small island in Southeast Asia, but it has a very good access in terms of transportation to neighboring countries, even to Indonesia. So the idea is that if you want to use this type of product for Singapore, the factory would not be in Singapore. The factory would be, let's say, in Cambodia, in Indonesia. Everything will be ready in the size, in the shape that they want. It's like a prefabrication system. And then it will be just shipped. You just ship the elements, and then you basically install everything on site according to the design guidelines. So you don't have to produce it in Singapore.
Let me ask something now. Myself, I would like to comment something, and then I'd like to hear you about sustainability. Let's say life cycle assessment, because if you are using something like 20% of resin, if you are using hot press system or to produce your material, if you have to transport it how about the environmental impact that your product will have? I think the beautiful of bamboo that sequestrates CO2, that is fast growing, but the amount of energy and emissions associated with the processing and also with the other material that you are using to produce your composite.
Right.
If you are still going to be negative in carbon.
Yes, so we did some life cycle assessment a year and a half ago together with some of our colleagues back in ETH in Zurich. So, okay, it's very, very, I would say, challenging to assess the life cycle of this type of material, depending a lot on where you produce it, how you transport it, and how you build it. So the reason that I talked a lot about prefabrication system was the fact that we could make everything ready on site. So once you ship it, basically you need less additional processes to make the elements into the shape, let's say into a house. But we did life cycle assessment. If we assume that we have a factory in Indonesia, we have the plantations in Indonesia, and we develop or we build the housing solutions or units in Indonesia, the product still remains carbon negative. So the product still remains carbon negative. But if we talk about shipping the product to Europe or shipping the product to Singapore, we still have to think about how we should do that, because if to Europe or to Singapore, you have to ship by shipping companies, and then you have to consider how that will impact the life cycle assessment. For that, we haven't done any calculations yet.
Yeah, this is a very good point. Important issue that you should do later.
Yeah,
because the next question is from our colleague from our association, our non-conventional association, the Professor Luiz Eustáquio Moreira from the Federal University of Minas Gerais. He's asking about what you think that are the main problems to use bamboo as a tubular material, the pole bamboo that is natural. Why not to make use of the natural beauty of the bamboo as it is? Why the industrialization? So he's asking about how in your country people see in tubular bamboo against industrialized. So that's the main point of his question.
Yeah, it's a very, very good point. I mean, when we started our research, we wanted to use the bamboo in its natural form, but we encountered with a lot of questions, comments, and visualization. First of all, we have visited some countries like Indonesia, Thailand, Vietnam. If you go there, you see a lot of housing made with the natural bamboo, even restaurants, luxury hotels. They have a lot of problems with insects, with fungi, with natural degradation of the bamboo. So every few years they have to do coatings, every few years they have to replace some elements because of these issues. And already when we talk to the owners, when we talk to a lot of construction companies that they do this tubular bamboo formats housing or buildings, they always complain about insects, fungi, natural degradations, and even UV. They have to apply coatings. They have to apply coatings not every 10 years, sometimes every 2-3 years, depending on the environment, especially those housing in the Indonesia. If they are close to the sea, then they have the sea breeze, and then they have more challenging problems. So the main problem with the natural bamboo remains in these 3 aspects that I mentioned. But when we transform it into a composite form, then you already have a material that has resistance against fungi, against insects, against natural degradation again, and you are maintaining the fiber strength. So if it's similar to wood composites. So the reason that we want to promote, so if you want to promote bamboo in its natural form, is very difficult, at least for this region, because the people see these problems. But in order to promote the bamboo, we have to convince the industry that we can take care of these problems by turning bamboo into a more, I would say, high performance material and highly industrialized material, something that is comparable and compatible and can be a good competitor for glulam, for CLT, and for LVL, laminated veneer lumber.
Okay, thank you. Thank you for your response.
It's a very good point. Thank you for raising it.
Yeah, I think it's an interesting question,
Yes,
because depending on the size of the infrastructure, sometimes it's really quite easy to use the natural,
definitely,
bamboo.
yeah,
So it depends on the application, of course.
Sure. Yeah.
Now we have one question from Fabrício Vitorino here from the Sustainability Center for Building Materials from the Federal University of Rio de Janeiro, the group which I belong to. Fabrício is a postdoctorate there, and he would like to know a little bit more about the production of the bamboo fibers from the cones, and also a little bit more details about the impregnation process to produce the composite.
As I mentioned, because of the time, so I didn't present every details. But in general, what we do, so the bamboo columns is round. What we get, we cut it into half, we flatten it, then we process it through the bamboo stranding machines. We get the strands out, then we process it into the second machines that we get the strand, slice it into thin and small diameters fibers. Then we put these strands together in one direction, and then we have basically resin dispenser machine that basically dispenses the resin every layers. And then you imagine you have something like a lasagna. You have the bamboo fibers, you have the resin system. You put everything into the mold of the compression machine, the hot press machine, and then you press. Depending on the shape of the mold, you can have different shape. So if the mold is U-shaped, then you get a flat shape. If the mold is V-shaped, then you get a V-shape. And in part impregnation, as I said, the impregnation is just through the resin system. So we have a resin dispensing machine that sprays the resin onto the surface of the bamboo fibers. So when I say bamboo fibers, I mean the bamboo strips, but they come into different thicknesses, different layers, and different widths. But they're all aligned in one direction. So it's not like a bamboo scrimper that Dr. Kraus mentioned, but would be very much aligned in one direction to ensure that we get the fiber strength as much as possible. But again, depending on the application, maybe I should add that depending on the applications, sometimes we have to do cross lamination.
Okay, thank you. I think the questions from the audience has ended. I myself would like to have my last question, and then later I will ask my colleagues from the board if they want to ask you something else. My question is mainly related with fire performance of your material, and also in case of fire, which kind of gases you can release to the atmosphere, and how dangerous can they be for the users in a occurrence of fire?
So in terms of fire performance, we don't have any certificates yet because we had to do the full-size applications. So this is our next step of research to ensure that we can produce a full-size column or beam to be tested with fire standards. But in terms of small samples, what we have tested was, according to Eurocode, was class B. So basically, you had like 6 hours of, I don't know the professional name, 6 hours of time for escaping, something like that. I forgot the English words for that. 6 hours. In terms of the gases that is being released, so it's VOC free. So there is no VOC gases in there. So if I want to compare, I don't remember the number of gases because this is a test that we couldn't do ourselves. We sent it to Zurich to test for us. In terms of the type of gases that being released is similar to LVL, laminated veneer lumber. So it is being classified similar to LVL. I don't know if you're familiar with LVL.
Yes.
Yeah, sure. Okay, perfect.
Okay, then, thank you very much. I would like to ask my colleagues if they have any other comment, any other question to you. Otherwise, we come to the end of this nice discussion, nice presentation and discussion. So I ask Professor Gavami, Professor Normando, Arash, and João if they wanna
just to say question. That you are a sympathetic person, and I like it a lot of you.
Okay. Iranian.
As yeah. I like Arash and Gavami.
Thank you, thank you.
Very sympathetic.
Professor, I think your microphone, Professor Gavami, needs to be turned on.
From the screen. I think from the screen you have to inactive.
Yeah, I think it's in the screen. The screen, yeah. Gavami, not the.
You have to click on the screen.
Okay.
Now he finds it. Yes, perfect.
Got it.
Oh, you know, I was in Iran many years back, because I think you were not born, I suppose, 35 years.
So.
And I gave lecture, and there was a professor from Babul.
Babul?
Yes, yes. He was very good. Unfortunately, well, he got fascinated with bamboo.
Right.
And he started to use bamboo, reinforced concrete.
Wow. Interesting.
We had yes, so you are in Iran now, as I see with the curtain. So could you find out? He started, yes, the Persian. He started to use bamboo as a reinforcing in Babul.
Wow.
I think, yes. Unfortunately, he passed away, you know, and yeah. So I don't know, maybe you could ask how long will you be in Iran? How long will you be?
I will be still here and for another 2 weeks.
Oh, too well. Ask to people, see what's happened to his.
Yeah, I can find out. Do you remember his name?
Yeah. You know, I forgot really. So many years back. Yeah, he was so nice, and he did. And unfortunately, like all in developing countries, he had lots of problems, but he fought.
Sure, yeah.
And that's why he passed away. But I didn't.
The name was Professor Sujudi, if you remember.
Oh, yes.
University. Manove Tabi, Gorgon University. Yes.
Maybe Arash, you can send me.
Yeah,
maybe Dr. Arash can send me some details. I try to find out. That would be great. Yeah, please.
Yes,
thank you.
very good, Arash. Sujudi.
Thank you.
Okay.
Very interesting to see what's happening. Developing country, huh?
Yeah.
Thank you, Gavami.
Yeah, I try to find out. Yeah.
Thank you very much for my lecture.
Gavami.
I hope we are seeing you more frequently in Brazil.
Yeah, sure. I would like to, definitely.
Okay. And Dr. Arash, if you have any final comment to Arash.
Yes. Again, thank you very much, Dr. Javadian, was excellent. I have many questions with my colleagues that did some tests about the test, tensile test, every test, and with detail. But I think now, after we can contact and follow this, solve this problem with you. Exactly. It's not a good time for ask every question here, but thank you very much. Excellent, and I'm very proud of you.
Thank you for organizing. Thank you for inviting me.
And then João, if you have your final comments, please.
Well, thank you very much, Dr. Javadian. And as I've said before, I very much enjoyed your presentation. And well, let's stay in touch anyway.
Sure, definitely.
Thank you very much.
Thank you.
Okay, so now we come to the end. I would like to thank you for your presentation, all colleagues for participating in this panel and discussing with you. And the audience was also a good question came from them. And I'm really happy in name of the Brazilian Society for Non-Conventional Materials to have you here with us this afternoon here in Brazil. And you can be sure that we can have many possibilities of collaboration here in the group of panelists, but also other people may try to contact you, and the association is open to make this connection. So it's a great pleasure for us to have you and to discuss with you about potential collaboration in the future. So I think this is a big field. Bio-based materials are going to find a nice and big market around the world. And I have no doubt about the future of bio-based materials. I'm quite confident they will find very good, very promising market.
Yes.
Thank you very much.
Yes, thank you very much. Thank you for Professor Romildo and everyone, Professor Gavami, Normando, Joao, and Arash. My pleasure was knowing all of you, and I hope that we can continue the collaboration in future.
Okay.
Yeah.
Thank you very much. Bye-bye.
Thank you. Thank you. Bye. Bye.